Welcome back, everyone. It's been some time.
It's a new year.
New year, same old us, but we have a lot of new things to discuss this new year.
Same old us, but new Quinly.
Yeah, new Quinley stuff to discuss. Yeah, there's been, uh, believe it or not, we haven't just been lounging around these last couple weeks, even though that's what you're supposed to do, but we've actually been quite hard at work. Um, Working on, well, in the you can see in the video title, working on QuinlyVision. And we've got some pretty exciting stuff to share today. Yeah, so we'll be going over um, where QuinlyVision is at now. We've got a demo that um, will show you like how to get involved in and how that demo is going to progress over time. And then we'll also be talking a bit about, how we're going to launch QuinlyVision. Yeah.
Yeah, and also sort of what we plan for the future. So where we see QuinlyVision going in the next, like, not just the next month or two, but in the next year, for example. So yeah, it looks like our mics are a little bit quiet, so Mateo's just fixing that. Hello to the people in chat. I see Matthew, Print Cord,
How's
Jay
this?
Schaefer. Yeah, how's our mic now? Let us know if you can hear us.
Yeah. Yeah, it's been a while. I guess we're out of practice. Where's Leah for this?
New year, new mic settings.
Leah's back at school. But her legacy lives on in QuinlyVision.
Yes.
Yeah, we've
Yep.
got
Picking up where she left off and going further than that.
doing some pretty cool stuff. Let us know how the mic volume is, and with that, I see a whole bunch of people are in now. And yeah, and we can get started, get talking about like thanks, Kevin.
It's the hair. We haven't cut our hair in a while, so
Yeah.
it's getting long.
Welcome, Sheldon. I hope everyone was able to keep safe over the break. Needs to be a little bit louder. Okay. I'll make it louder once more and then we'll get started. And then if it's still quiet, let me know. I'll put it at, what do we usually put it at? Like 6?
Yeah. Maybe 10 actually. I've done 10 before.
10? Okay.
Yeah.
Okay.
So on this stream, we'll be talking 3D print fails and failure detection and how we plan to improve our model over time. So maybe just to get some conversation going in the chat, let us know what kind of fails you've been having recently on your printers. If you've been, struggling with a nozzle blob or a warping on your prints or something, just let us know. It'd be
Yeah.
nice to see what kind of tell us your issues. We want to know.
Yeah. Actually, okay, I think we're all good to get started. Hey Al, welcome. I've actually been printing over the last couple of days, printing some fails on purpose and recording them. It's kind of hard to see, but there's like
Some stringing going
some
on.
intentional stringing. Some of the ones we don't get on production very often. Some bridging issues. And actually, this one's going to be interesting because this is a real test. These are like less common ones that we want to run through QuinlyVision and give examples of. But here's one where it's actually like zits on the surface of the print. It's this is one of those things that you wouldn't really expect failure detection to work for, but it's something we're trying to get it to work consistently for.
Yeah, it's actually a fun challenge trying to get those failures to happen on purpose. Like
Yeah.
I had to really destroy my slicings profile to get the stringing and the blobbing and stuff to happen. It was quite fun.
Yeah. Matt says he had a weird failure where the stock hot and fell completely out of its mount.
Oh wow. So the screws came off.
Yeah, I wonder what that would be detected as.
Do we have a screw falling off detector?
No, but actually that's a great that would be a great, so one of the things we're going to talk about today is we have these 14 types of failure detection, but we're really going to go through and see how we can work with everyone that's here, because this is really going to be a community project, but see how we can work with everyone to develop more and more types of failures. So I guess if hot ends falling out of their mount are a common failure, as part of this project, it would be possible for Matthew to report that kind of failure and actually, and if other people see it, we can start like logging it and trying to build inference around it.
Yeah, I mean that could be a weird object is on the bed that didn't used to be on the bed kind of issue.
Yeah,
Like maybe we could have an unspecified hardware failure issue. You know?
that's actually a good. I wonder if that'd be possible to do with our current one, because we do detect the print. So if there's something that's not the print,
Yeah, like
could
an
we?
overlapping model.
Yeah, like
Hmm.
hot end shaped non-print item on the print bed. Um, Sven says he has some problems with the mosaic palette and that this would QuinlyVision would be really useful for it. I'd love to hear more about like what specific types of failure you're getting, because we might be going through them uh, tonight. And yeah, okay. So what should we talk about first?
Well, let's talk about like why we're doing QuinlyVision, right? Let's get into some of the what's our vision? What's our QuinlyVision
Okay.
for this project? So as you guys know, we're Quinly is automation. Quinly is automation for 3D printers. And one of the main goals of automation is to make 3D printers super reliable so that they can print multiple parts in a row without needing constant maintenance and tinkering.
Hmm.
But that only gets you so far. So like a very reliable 3D printer can still fail if it's given bad G code. And so there's no way for us to completely reduce or remove the chance of anything failing. So we need like a second layer of defense that'll catch things when they go wrong because it's inevitable that things will go wrong eventually.
Hmm.
And so this is the safety net. QuinlyVision is a safety net that allows the automation to perform without damaging your printer, without causing it like incredibly fails. Um, these two technologies combine together to make something that's better than each individually. So this is why we're working towards a future where we have automated 3D printers being watched by an AI, getting constant feedback, and even possibly improving the prints on the fly or in like an iterative process without the need for a human operator to do all this stuff manually.
Hmm. And I think it might be helpful, like in terms of our future vision, to start moving away from the label of failure detection and more like print monitoring or print quality monitoring, because
Yeah,
our goal with this and what we'll be building together is, um, you know, right now the stuff you can get out there will catch a print once it's failed, and once it's failed, that's kind of too late. It's created a mess on your printer. The mess isn't getting any worse, but it's still there, and you still have to go and deal with it. Whereas what we're really trying to push towards is, okay, how soon and how quickly can we catch these failures? So, an example, and different failures happen at different parts during the print, right? So, something like spaghetti is generally like the worst thing that can go wrong. It means that
yeah.
something in your print has gone terribly wrong. It's shifted, it's moved, it's not in the right spot, and now your nozzle is extruding spaghetti everywhere.
It's
Uh,
usually like the result of some other failure that happened earlier.
yeah. And, as I showed kind of with these models, failures can happen, and the model might not even create spaghetti. You might just have a failed model that is like partially failed. This is unusable because it's the quality is not good, but it wouldn't be detected by a failure detection system.
Yeah,
So,
because it's a defect rather than a complete fail.
yeah,
It's still
exactly.
finished. The part would have fallen off by, if it was an automated system, the printer would have knocked that off fine.
Hmm.
It just you would have just created like 20 useless parts,
Yeah.
and that's not what we want to do.
Yeah, so the goal with our stuff and the reason we detect so many different types of failures is um, spaghetti's kind of like a last resort,
Hmm.
but really we want to see symptoms of like impending failure coming on earlier. So things like detecting warping, detecting layer shift, even detecting issues with your first layer. Um, we want to find all those before the print continues and then give um, you as the operator the choice, like, you know, does this look okay? Should I continue the print? Will the print be usable? Or should I just stop it or abort immediately?
Yeah,
Mm-hmm.
so having more than just spaghetti is kind of our main goal here.
Mm-hmm.
And I guess we have to do things slightly differently in order to catch more than one failure mode. So maybe should we get into like what we do in a slightly different way than other methods for detecting, failures?
Yeah, so I guess the main challenge with QuinlyVision that we're solving is that um, when you're trying to catch something going wrong very early into the print, it's not obvious. So you can't use um, just simple like image recognition
Hmm.
um, because it might be really small. It might be some very subtle change over time. It might be that the camera you're using is not good enough to see it right away.
Hmm.
Um, so we have to employ different techniques for different types of failures. But essentially, like there's instead of just image recognition, there's like a whole pipeline of um, where we take an input image and we might do some processing on it. We might, cut out the background, cut out certain parts of the image depending on what's printing, and then change the colors in a certain way. And the really interesting thing that we're looking at now is actually taking many, many images and using a set of like photogrammetry techniques that will help us extract more information than is immediately visible from those images.
So you're
So,
doing like instead of one picture analyzing it, taking all the information and saying, okay, this is all we have.
mhm.
You're actually combining the data from like a series of images and using all those together.
Yeah, for some types of failure, that's useful. For other types, it might not be. Like for example, like warping is something that starts off very slow and it happens very
Yeah.
slowly over time. Like warping can happen over the course of hours. So, once it's become bad enough for image recognition to detect, that warping might have started hours ago. It might have started with a bad first layer even. You don't know.
Yeah.
But if we're looking and like stacking images through time and looking for subtle changes over time, you can catch that type of thing much, much sooner.
Right.
So yeah, for like kind of some of our goals are, or some of the goals that I've been sort of keeping in the back of my mind are like trying to detect certain failures like within a minute of them occurring and trying
Yeah.
to get that number as low as possible.
Well, that's actually a good point there. So when we detect a failure, we want to be able to actually respond to it automatically whenever possible.
Hmm.
So if a 3D printer is unattended and there's no human to go out and like remove the spaghetti from the print, for example, we actually want to catch the print as soon as the defect happens rather than after it's become a mess that you need a human to deal with.
Yeah, because like something like this would pass like failure detection because it didn't fail. The print completed, but
It's got zits on it if you can't see.
yeah, it becomes like because the surface is so bad, if you're using printers for production, it's like this part is pretty much useless.
Yeah, no one
Um,
no one would want to buy that.
so you need some way of defining what a failure is, like it to your parameters as a print operator or as a designer. Um, you need to be able to have control over like what exactly constitutes a failure rather than just the machine exploding, right? Like,
Yeah.
because that's where we're at now, and printers don't have sensors built into them that are smart enough to understand when this kind of thing goes wrong. So that's what we're trying to do with QuinlyVision is add this layer of sensing to the printer so it can make more intelligent decisions about like when to stop or when to pause and check with you, or in the future even, you know, if we catch a failure early enough, see if we can recover.
Yeah. Yeah, it's a good point because 3D printers don't come with many sensors other than the ones that are absolutely required.
Yeah.
You get temperature sensors because that's the thing that can potentially cause some fire, but um, like higher end machines like automated manufacturing equipment come with lots of fail safes built in and sensors to detect fails. But 3D printers don't have any of this. So um, this is like a first step in the community to actually creating some sort of sensor to respond to fails. It's not a thing in the 3D printing community.
Yeah,
Not as
usually
much as it should be.
the person is the thing that responds to the fail. Like
Yeah,
you are the
yeah,
one staring at your print saying, I'm gonna cancel this. It's shifted a little bit and I've just wasted all this film, and like it's
yeah.
not, there's no closed loop. Um, okay, so maybe we should get into some of the other techniques. So we talked about photogrammetry. Something that I've been experimenting with very, very recently. So um, I don't have too many things to show, but is there's a new area of AI called um, neural radiance fields. And it sounds really complicated, but basically what it is like 3D scans
Should I get the
from
demo up?
photos. Yeah, why don't you put it up? Um, and this is one of the things, like this is going back to how we want to use QuinlyVision to close the loop. We want to have a way of very sensitively detecting our output, seeing what's going on, and comparing it to our input. And in the case of 3D printing, our input might be a 3D model or a G-code file, whereas we have no way of sensing our output. And that's where QuinlyVision comes in. QuinlyVision can take images, slice and dice them, process them in different ways depending on what we want to do. And then what we want to build is a pipeline that takes that observation and relates it back to the um, the input file. So this is one of the papers that I've been looking at, um, which might be a cool concept uh, in the field of like radiance fields. And what it basically does is if you give like very disparate images of um, like you can just take a couple of sparse photos and feed it through this algorithm, and it'll actually reconstruct a 3D model based off of these photos. And the really cool part about this is it's like very cheap to run in the sense that you don't have to take very many photos. But imagine in the QuinlyVision dashboard if you had not just a live feed of the print that was going on, but you actually had a live 3D view so that you could look at multiple angles at once, um, and compare and see like whether the model is coming out good compared to your like your G code or your input STL. So like instead of, you know, being at the printer and like bobbing your head and looking around the model, we'd actually be able to reconstruct these 3D scenes in the QuinlyVision software so that you could have a 3D view completely remotely.
And it would
And
be a 3D view of the actual model being printed, not just a G-code rendering. So it would actually be using real photo data
yeah,
of what's being printed.
so you could even one thing that we're thinking about, and one thing I wanted to get everyone's feedback on is, you know, would it be useful to have like one panel where your G code is rendered, and then one panel where this 3D model is rendered from the images that have been taken over time, and being able to compare those two. yeah, that's just an idea that I've been messing around with, and I'm trying to see whether we can get it to work with a 3D printer because, as you can see here, this is like people walked around the tank in this example and took images of it. I'm trying to see if we can move the 3D printer platform and camera in a certain way in order to be able to construct these scenes. Um, so yeah, you as an operator, like, and again, this is just highly experimental, but the idea is that you as an operator could get like a 3D view of your printer remotely. But it also means that QuinlyVision would have a 3D view of your model remotely. And so it would be able to gain better inference of certain types of failures if it was actually able to peek around corners like that and not just look at a flat image.
Yeah, like even just being able to have, a few degrees of rotation can give you a much better idea of sort of if a overhang is failing or not. Yeah, it just sometimes you can't tell based on one angle, but if you get like as your bed moves forward and backward, you can see like, about 10 degrees of difference from the side view. You might be able to tell if there's a failure when you wouldn't have otherwise been able to tell.
The browser's going insane. But yeah, so that's one of the ideas that we kind of wanted to put out there tonight and see um, what you guys thought about it.
Someone says bullet time print monitor.
Bullet time for monitoring. Yeah. As your like printer self distracts. Um, that'd be great to see level failure or success and G code and compare them side by side. Yeah, like imagine 3D views of both that like when you scrolled on one, it would actually scroll on the other and you can compare them side by side.
It's really cool that the AI, there's so many like developments in AI that are very like timely for this because
Hmm.
like AI is such a new field and like improvements are becoming, coming like every few months. Things are getting an order of magnitude better, which
Yeah.
is really cool to see because it's at this point where we're trying to use this stuff for real applications and it's actually getting to the point where it's good enough to implement into something like QuinlyVision.
Yeah, Matt brings up a good point in chat saying, would the print movement interfere with the image? I think we could exploit the print movement to make the image more accurate.
Yeah, you can get different angles
Yeah.
using the print movement, so I think it's actually a benefit.
What about an AI bed leveling tool? Okay, that was the other thing that we wanted to talk about. How about 8 cameras around the bed and can snapshot a series between layers? I think that would be really cool, but like insanely expensive to have 8 cameras. Um, one thing I'm testing with, or I will be testing with in the next couple of days or so, is seeing how much we can get out of just 2 cameras. Even one camera, like you can get a pretty wide field of view with this, but if you had 2 cameras, I think you could get the whole 3D model. Um,
Yeah, it's a good question actually, is do you need to have a full 360 view,
yeah,
or are you able to tell if something is failing like 90% of the time if you only can just see one side of your print?
yeah.
Like maybe, I mean, whatever, this terrible looking thing would look bad from a ton of angles. The only way it wouldn't look bad is if you looked at it like straight on like this. But
Yeah.
even if you can get like a few degrees like this of rotation, you'll be able to tell that there's something bad going on underneath.
Hmm. And even without the fancy 3D stuff, having 2 cameras like on each side would allow you to see failures from both sides. But yeah, that's a question that would be posed to the community, and a discussion that should probably happen in our Discord, which is, um, like, what does 2 cameras make sense, or do most of you guys as 3D print operators agree that you only have to look at it from one view and a couple of angles? Um, yeah, because that affects how QuinlyVision will be shaped, and we can do all sorts of experiments together. So I think, yeah, that's like one very exciting thing that I think will be interesting to keep track of.
Yeah, the AI for bed leveling. My point on that is there's a perfectly good sensor built into most printers for bed leveling, which is the VL Touch or
Hmm.
the auto level. So instead of using a camera to judge bed level, I think a much better thing would be to actually incorporate the probe data instead. and analyze the probe data, see if that's um, able to be used to determine if your bed is level. I mean, you have a bed visualizer, like that's not new.
Yeah. I think one of the big things as QuinlyVision matures and as we get your guys' help to build it, it is going to definitely be comparison between the 3D model and the images.
Hmm.
And um, one thing that I think um, would be interesting too is we've been throwing around the idea of having a second camera, not like a second camera on the opposite side, but actually a nozzle cam, like a probe camera. Um, because that can also give you like going back to the idea that um, we need to be able to catch failures very, very quickly.
Yeah,
Um, a camera on the outside is good for catching pretty macro failures and like large things that manifest over large areas. So things like warping. Um, but a camera on the nozzle would be very good at catching very small immediate fails with the extruder, with bridging, things that are inside the print even. And then combining those two and feeding those both into the QuinlyVision model, you could actually say like, um, maybe the probe camera is seeing one thing, and it's
hmm
like, hey, can I get a global view of this to confirm whether what I'm seeing is right? And so then the model will take in a snapshot of like the wider angle, the normal view.
yeah.
And if both things are seeing the same issue, then you can be really confident that something's going wrong.
Yeah, well, that's one of the aspects of QuinlyVision is not detecting fails, but detecting defects. So th one of the kind of modules of QuinlyVision is specifically named the defect detector, that looks for things like stringing, zits, poor overhangs, things that don't cause full-on failures
Hmm.
necessarily, but things that will cause your print to be useless, and things that you'd want to know about as an operator. So I like the idea of a nozzle cam. I think they're called endoscope cameras, but the really close up,
Colonoscopy cams.
yeah, whatever. If you actually use it for medical purposes, but I think CNC Kitchen did a video where he attached it to his nozzle, and
Yeah.
you can see some really high detail close up views, and that would be great for checking up for stringing or zits or
Even first layer. Like
yeah,
what
terrible first layer.
it
Yeah.
would be so easy to observe the easy. That's like implementing it would be hard, but conceptually observing like the line thickness as your first layer goes down.
Hmm.
If you know your nozzle width, you should know what the line thickness should be.
Yeah.
And you would have to do some like you could make some reference points so that you can get real measurements, but you could watch like does the line thickness change as the nozzle is putting down that first layer? And if it does, then you know your bed is on level, and you'd actually be able to map, um, I think, pretty accurately like what's going on just by observing the line coming out of the nozzle at different parts of the bed. So that's also one of those things where um, it'd be interesting to hear community feedback on like how something like that might be implemented. Is there a clever way we could do it so that it worked for every print, or is there some kind of routine we would have to do?
Hmm.
Yeah, I'm curious to hear what people's thoughts are. Um, Matthew was saying there's only one camera port on the Pi. Um, you could use USB cams, which is kind of what we're planning to do anyway, since um, internally we've moved to the ROC 64 microcontroller, and that only has USB ports. But as long as you can get an image to the model, it doesn't really matter how you get that image to the model. Um, what about something similar to Clipper's tilt calculation tool where it tells you how to, yeah, like you could look at the G code and see what the first layer height should be, and then look at the nozzle width and see, like, look at the line width and see, you could probably map it to the layer height and see like how much you're actually off by. Nozzle Cam could detect wet filament as well. Yeah, like any kind of bubbling or popping. Uh, yeah, you could totally. I don't think it'd be super difficult. Bend over cams. Yeah, that right. That's what they're called. Bend over cams.
That's a new one. Heard that before.
Yeah, just don't bend near your printers, and you should be fine. Um,
So we do have a demo of this
yeah, let's
QuinlyVision. Let's show the
let's
demo
show the demo.
because yeah, this is what Max has been working on, our awesome developer.
Yeah, and I think Max might be watching too, if you have any questions for him directly. But
Shout out to Max.
this is this is a oh my god, my mouse has disappeared. Okay. So this is kind of a concept that we have for the UI. And it's got a few ideas on here. And I guess one thing I should say is this is like a dev demo. So every couple of days, we're going to be adding more and more things, things, things that we're working on, things that we've discussed tonight, and also things based off your feedback. So I'll show you guys where you can sign up for a mailing list, but check back on this every couple of days because over time you're going to start seeing more things in the demo, things you can interact with, and we'll talk about some of them. Like in a couple days, the live model will actually be accessible from this website, so you'll be able to get live results from the alpha model that we have trained. Yeah, so keep checking back because this is going to be changing a lot over the next couple of weeks. So right now it's got, I know we've been talking about fancy camera views and stuff, but it's got the one main camera view. And you can like click on a couple different images. But the idea is that in the middle pane, you're going to have your like analysis, I guess, view where things like a live view of your print or even that 3D model view we were talking about or a nozzle cam, those would all show up here. And right now we just have some images you can select from at the bottom. But basically, so you got your analysis on the right, and then on the left side, you'll actually get like a breakdown report about what the model is seeing, and what's going on in the print. And so at the top, you have like the failure types, it just, marking up what you're seeing. And this is really important because it will tell you if there are multiple failure types, it'll tell you what those are and like how much of each one it's seeing. In addition to just boxing them on the image itself, this is really good for doing analysis on like if you have multiple failure types, seeing like, oh, okay, if I'm seeing these 3 failure types, I know I'm getting this kind of problem. And as an extension to that, lower down here, there's actually going to be live suggestions. So this will start out as suggestions for you as an operator on what might be going wrong with a printer and how to fix it. But over time, as it gets more and more robust, this will actually become like live action. So, in this case where the nozzle is clearly clogged, it might automatically set itself up for a cold pull so that as soon as you are able to go and deal with the printer, it's already ready for you.
Yeah. And actually another cool one is like say a heat creep, for example, if it notices that no extrusion is happening, some printers like the Prusa have built-in calibrations that Quinly can access to check if the fans are actually running.
Mm-hmm.
So it can pause the print, say, oh, the hot end fan actually isn't running. You need to check your wiring because it's not working the way it should be.
So yeah, so basically on the right here, exactly that. There, it'll start out as suggestions, but as you know, as the community, as we put more and more response information in over time, eventually that those can become like automated routines. And we're
Hmm.
even toying with the idea that, you know, you could set up like if I detect these failures, run a certain script or something.
Yeah.
That was one of the things we were talking about, I think.
Yeah, because certain combinations of failures at the same time will indicate maybe a more particular type of failure. Because maybe under extrusion and then no extrusion, that could potentially be like a nozzle clog that
Hmm.
started as a partial clog and then turned into a full clog.
So I think before we talk about this any further, if you guys want to like keep updated on this, because this is again, this is going to be changing a lot. Like every couple days, there's going to be new stuff added. Um, if you go to our website and then click on QuinlyVision, I wish my mouse was visible because it's making it okay.
Mateo's mouse just like completely disappeared.
Um,
That's great.
you can sign up for the list here, and then you'll be like, not only will you be the first to know when a change happens, but if you're, you know, making suggestions, you'll also be able to see like whether your actual suggestions are implemented, and you'll be able to test them out. And you'll also be able to watch as the model improves because, yeah, we're very, very early on in this. And, you know, it's like, um, I don't know, what does Steph say? Steph said it's like a baby. Like right now, it's QuinlyVision is crawling,
Yeah,
but
you get to watch QuinlyVision grow up.
yeah.
You be there through its whole life. And actually, a cool thing here is since it's new and you guys are here with us while it's new, you have the most like control over how this grows and how this matures. So
Hmm.
if there's something in QuinlyVision that you think should be a certain way, you can tell us, and we care a lot about what you think because you're here watching us now. So we'll do our best to implement that. So every like everyone here who's early watching QuinlyVision grow has a lot more influence over the future of this.
We got some people joining. We got Clinton. Is there a way to be visualized through Quinly? Sorry, just joined.
Bed visualizing, I think that means.
Oh, bed visualize. Um, if you tell us how you would like it implemented, I'm sure we could figure something out. Uh, and then Clinton's also offering analyzing photos via GPU. Actually, maybe I'll contact you about the neural radiance field stuff that we were looking at earlier. In case you didn't see, and in case anyone is joining partway through, one of the things that we've been looking at is using um, certain techniques to actually reconstruct the 3D print as it's printing. So, I mean, something that came to mind to me just during the stream is like, imagine you could have a 3D time lapse of your print being built up, right? Like you take a couple of these throughout the print and you can actually watch, you know, from all angles. Like a 3D time lapse would
Yeah,
be
that would
really
be
cool.
really nice.
Um, but yeah, like for that, for this, I think I'll take you up on the offer. Um, but yeah, anyway, so going back to the UI, this is like the concept that we have now. Um, yeah, in the middle you'll have the analysis. On the side you'll have possible fixes, and coming up, where as you know, we built out the layout now, but we're going to make it more and more interactive. So coming up, there's going to be things like we're thinking have like a quiz where you basically you're given a certain amount of time to look at an image and highlight like all the things you think are wrong with that print, and then it compares it to whether like QuinlyVision was able to get as many as you did.
Hmm. I think I actually kind of want to see the ability to see what other people thought.
Yeah.
too. I think it would be
Oh,
cool to
that'd
see
be
like
so cool.
the average answer and what QuinlyVision's answer is, and then what your answer is, and
That'd be that'd be so cool.
compare all three. I think that'd be
I
nice.
think that'd be a good idea. That'd be crazy actually. And one of the other things we're thinking about is like not just having this as a detection system, but actually working on building the community around it. So, for example, like if you see something really weird in your print that there's like no category for it,
Hmm.
and you want to create a new category for failure, we're thinking like giving you the ability to highlight it and post it for other people to see. And then if other people are seeing a similar issue, they can post their images and actually everyone can work together to start building inference for new categories of failure. And then of course everyone the idea is that everyone will be like credited under like whenever you contribute to a failure, you'll have your name like on a credits list permanently under that type of
Yeah.
maybe it's like a list of shame because you don't really want to be under failure modes, but
Well, if you have really cool failure modes,
yeah,
I think that's a badge of honor.
I think
Like
it'd be fun.
I remember that like shout out to Flipsaw when we were printing those DNA spirals and one of the legs broke off and it still printed. I thought that was the coolest
Yeah.
fail ever. But that's something we'll be doing though. So we're gonna be having a leaderboard essentially where um like whoever has contributes the most gets their name higher up on the list. Um, so this is our platform for actually like a community project. This isn't just supposed to be 3DQ us working on it. Um, we're building the platform, but um, a lot of it is actually you guys using the platform and like submitting images and checking out other people's images, quizzing yourself, and um, actually improving QuinlyVision uh, by interacting with this demo.
Hmm. Yeah, and I think in addition to that, um, yeah, I think this could be a really powerful way to improve your skills as a 3D print operator
Mm,
because it does take a lot of the troubleshooting out of things. So you can focus on like if if somebody's had this issue, it's kind of like on you said on Prusa's manual, they have a comment section under every single step in the manual.
yeah.
And if there's problems in the manual, somebody's going to write a comment about it, or if they're having issues with a certain step. We kind of want to do something similar here where under each suggestion, or you could post your photo, um, people would be able to comment and help you out with an issue you might be having. Or if QuinlyVision makes a weird suggestion and you're like, this is totally wrong, you can put a comment there. And if enough people agree with you, you can actually influence the model and be like, okay, we'll change it. Like, like yeah, what were you saying? Like, you could roast Quinly Vision.
Roast QuinlyVision, yeah.
You just, totally roast it and be like, you know, it's detecting the completely wrong thing, and then if enough people agree with you, you can like the model will take that into account.
Yeah, so I like to like one of the things I see a lot on like 3D printing forums, and I hate this, is like when people give advice that's actually the opposite of solving the problem. Like if people give advice that'll actually lead you down a rabbit hole that'll get you nowhere, I'd be
Yeah.
like, oh, it makes me so mad to see people like, oh, you got a clogged nozzle, level your bed. Like, no, that doesn't work like
Yeah,
that.
yeah,
So if Quinley suggests, I suggest you level your bed because of your no extrusion, that's wrong. You have to say Quinley no,
yeah.
and then leave your message, roast Quinley a little bit, but
And then
in a
and
nice way.
and then come back a few days later and see if it's still wrong or
Yeah,
see if it's improved and see if it's not getting wrong. So that's going to be the cycle with this demo is going to be um you know, every couple of days, things are going to change. There's going to be new stuff and new ways to interact with it. Um, and the more people that are interacting with it, the faster you'll see those improvements happening. So,
mhm.
um, definitely share around this page, the QuinlyVision page, Because as more and more people start getting on and interacting with the demo and providing feedback, we'll know what direction to steer this in, and what's most critical for you guys as an operator to be able to, use your printer in a way that doesn't cause you dread and anxiety every time you start a 12-hour print. Sounds good.
Yeah, it seems like people want a bed visualizer built into Quinly.
Saw one day, yeah. I don't see why that would be too tricky. And there's actually, I'm trying to find the image. I don't think we have it here. There is an example of QuinlyVision picking up bad first layers. It does it in two ways. There's one where the first layer peels, which it can catch, called first layer detach. And then there's one where if the first layer is like too smushed and you get those ridges,
Yeah.
that one's called, I think it's just called bad first layer. But even that, like somewhere between those two failure modes is a perfectly level bed. So we can already start like doing some kind of bed leveling with QuinlyVision, at least a
Yeah,
little
like I
bit.
guess if it doesn't even pick up a little bit of bad first layer stuff, then you probably have a good first layer because
Yeah,
you're not getting artifacts in your print.
yeah. At least to start with, it'll be like, okay, if I have this type of bad first layer, it's too low. If I'm getting first layer detach, it's definitely too high.
Mhm.
But yeah, over time we'll hone in, and eventually, maybe with the endoscope cam and in combination with our first layer detection, we do have live C adjustment. Like for me, that would be the dream.
Yeah, well, I think once you have the nozzle cam, you can actually see if your nozzle's too low,
Yeah,
you'll be able to see that it's too low.
yeah,
Um, and even if it actually starts peeling and you start to see plastic covering up the nozzle when it shouldn't be, that could be an indicator that you have to change your temperatures or speed or bed level.
I think that's what I think that's what it detects. The first layer detach.
Oh yeah. Yeah, because if anything's in front of the nozzle on the first layer, then you probably have something going on.
Let me try to pull it up.
Oh, you do have there is, I
The
guess that the
driver.
demo of you doing it, it's the MP4 there.
Oh yeah, okay. I'll play that while I try to find that image.
Yeah.
So this is just like a demo of the alpha model running um, manually.
So this is what it looks like on Mateo's
Yeah,
desktop.
in a VM. Yeah, this is not like this is not very
Mhm.
sophisticated. This is alpha, alpha, alpha. Max is putting something up in the next couple of days on that demo website that you can get to if you when you sign up with your email. Um, that one you'll be able to interact with, and it won't look like this. You'll be able to go through the UI. Okay, so let me see.
Thanks, Jamie, for the support. Good luck for all. Well, good luck with all of this, guys, he said. And a question from Matthew. Would Quinly buy the cameras in bulk and sell them as part of a kit? So yeah, we're actually planning on providing a QuinlyVision hardware kit that has like a camera and lighting setup that we feel is like most suitable for QuinlyVision. And we'll be providing that as an add-on actually in our Kickstarter. So if you don't have a camera for your printer yet, you can get the camera kit, and that includes some lighting equipment too. And that'll be for what we determine to be like the best setup for QuinlyVision. Um, and there's just going to be more information on that once our Kickstarter
Mm-hmm.
um, goes live. So I don't have all the details yet, but we will be providing uh, cameras and lighting options.
Yeah, there will be a recommended hardware spec, and you'll be able to get that as a kit for each printer. Um, yeah, and we're even it might not just be one camera. We're even like the endoscope cam. We're even thinking about, could we use sound in a meaningful way? Like
Mhm.
imagine um, you get a notification from QuinlyVision, hey, something's going weird with your print, and you get a clip of the sound, and you also get some pictures, or you get a short video in your email, so you can listen to and see if anything's going wrong. Um,
Yeah, like when I'm not when my print's failing, and this is rare now because I'm pretty good at not failing, but when they do fail, it's I usually hear it before I see it. Um, if like some weird crackle is happening in the background, I'll be like, "What is that?
yeah.
That's not good. I need to go check it out."
Yeah, there's some things that you can't see, like wet filament. If your filament is popping, it means it's either wet or you're printing it too hot. But you wouldn't see that until like very far into your print, or if you had a very high resolution camera.
Hmm.
Whereas with a microphone, you could detect that almost immediately. Another one would be like motors stalling and grinding.
The extruder, the click, click, click.
The clicking. You could probably hear a layer shift before the entire layer shift gets printed as well,
Yeah, true.
because that makes a lot of noise too. So there's like all sorts of stuff like that um yeah, now I'm imagining a quiz on the demo site where it plays sounds and you have to guess what kind of failures each sound is.
Yeah, well, yeah, we'd have to have like a little recording studio in our office where we just record fails of like printer failing
Yeah,
for a while.
that'd be kind of cool. Um, so what else do we have?
So I guess areas where we want to like continually improve QuinlyVision. So what are some like what like in the future, where do we want to like where do we want QuinlyVision to be like say like in 2 years from now? If it's like already a product, it's working,
Yeah,
what do we want to actually be able to accomplish with QuinlyVision? Like how is it going to change the way we print?
I think the main, at least for me, the main thing is going to be um, not having to worry about major things going wrong, my printer getting damaged, just being able to start a print and kind of walk away and
Hmm.
know that either uh, if something does go wrong, there's something watching every single, you know, every single second of the day. Um, QuinlyVision is watching, monitoring, and at that point, I think we would definitely have self-correction
Yeah.
put into it. So if something starts to go wrong, it's either going to try and fix it itself based on things I've told it to do or default settings, or it's going to safely and immediately stop the printer and notify me so I can go and take a look at it.
Yeah.
So I think that's in 2 years, that's what we want to be. Something where um, anyone really could just start a print and not worry about destroying the entire machine. I remember like in high school, there was a 3D printer and like no one was allowed to use it because of fear that like it was an expensive machine and that someone who doesn't know what they're gonna do is gonna break the printer.
Yeah.
And you would think that like, you know, having used 3D printers now for what like 7 years,
Hmm.
um, that's not a concern anymore. But it still is a concern. Like every time I start a really long print, I'm like, oh, I'm gonna have to check on it a couple times. Like I
Yeah.
don't, and if I'm lazy, I can't be lazy because what if something bad happens and like my whole hot end gets destroyed and I have to buy another $50 hot end? Like there's all of these things going through my mind when I'm starting a new print. Um, and I don't want to have to worry about that. And it would be even better if the system was able to just self-correct too, so I don't even have to be too careful about fixing or like agonizing over the slicing or whatever.
Yeah. Well, I guess that's a good point is the peace of mind. Like that's something that we've tried to fix with Quinly too, is the like the mental strain of having to constantly think about restarting your printer.
Hmm.
That's something that Quinly fixes. And now I think the mental strain of what if my print has failed,
Hmm.
when that goes away because okay, QuinlyVision will catch it, I think 3D printing will become a lot more fun.
Yeah.
Because when things go wrong, they're not going to go that wrong because the printer will be paused and you'll get a notification saying that you need to go check it.
And here's ways you can fix what's going wrong too.
Yeah, and here's how to fix it. And actually, by the way, we already fixed it because it was just a layer shift. So we pushed the print off and started it again.
Hmm.
Um, like there's so much like potential for this to be like such a hands-off, like 3D printing to become such a hands-off hobby that it's actually fun and accessible for more people. It just requires some complexity to get there.
Like, you know how frustrating it is when a paper printer does not print your document correctly? Like, it's so annoying, right?
Yeah,
Like, I
we
was,
it's like 2022. We've had
yeah,
printers for so
like,
long.
yeah, I was just last week, I was trying to print a shipping label and it was like skipping every other line. I'm like, I don't know how to diagnose this.
Yeah,
I don't want to spend an hour fixing it. Like, why do people think about 3D printers in a different way? Like, it should be a tool for you to get your work done. It
yeah,
shouldn't be a tool that breaks every third print that then you have to dedicate an entire afternoon to figuring out like why this one print is coming out in a weird way. Like
yeah,
you shouldn't have to be able to do that. You should just be able to get what you want out of your printer. Um, and you can't do that until there's a system that's smart enough to see these issues and self-correct these issues, which is what QuinlyVision provides.
yeah. And schools for QuinlyVision. Yeah, that's a good point because it would be nice for if students that don't really know what they're doing slice G code and something goes wrong in the middle of the night, you don't want your hot end to be covered in a huge glob of plastic in the morning. You want maybe at worst just a failed print on the plate that you have to
Hmm.
scrape off.
And it sucks as a student too. Like if you just destroyed the hot end on a $2,000 machine, um, they're gonna feel dejected. They're not going to want to. They'll be afraid of sending more prints. They might not even be allowed to send more prints to the machine if they cause
Yeah.
damage to it. Like it's not good for the accessibility of 3D printing. Um, yeah, I think it would be really useful in education, especially with um, being able to have a built-in like community forum, being able to access suggestions immediately, and then of course all the
Mhm.
fail safes. But it's really good for education because I don't know how many times when I started 3D printing, I would have an issue and not even know what to search because I didn't know what it was called.
Yeah.
And then you have to like go through these giant catalogs of different, they're all picture based too, like the manuals online. You'd have to
Yeah.
go through them, find your failure, and then you don't even know if the advice is good. Like that's one of
Yeah.
the things.
Like when I see people post online, a lot of really new people are like, I don't know what this is called. I couldn't find it online. Just
Yeah.
someone please tell me my print looks terrible. I just don't know what to do. My hope for QuinlyVision is that, if you have this installed on like a school printer or a work printer where a lot of people are using it and they don't particularly know what all the fails look like, they actually get feedback right away saying, okay, yeah, in this case, you needed support material there because there was an
Hmm.
overhang that wasn't supported. Or, you need to increase you know, reduce your first layer speed because, your first layer peeled up immediately.
Yeah.
If people actually can see what went wrong and how to fix it, like as a beginner, that'll help people get better at 3D printing
I think
faster.
that extends beyond education as well. A lot of 3D printer OEMs were heavily marketing towards like office use for engineering offices, right? And um, for like a you know $1,000 to $5,000 machine, those offices are not going to hire a 3D printing technician. So having a system that's able to educate people and at the same time keep the printer safe from bad G code is would be really useful for even environments like that. Like um, because what you see is you know, an office will get a 3D printer, and then over time, the one guy who knew how to use it moves to a different department, and now nobody
Hmm.
wants to use it because it's probably not going to print well or it's going to break.
Yeah.
Um, and like a lot of printer companies try to get around that by providing profiles, by providing support. And I think that's a really good way to do it. But why not use an automated system like QuinlyVision to catch all of the like really low hanging fruit and immediately catch issues? And then, you know, if it prevents a failure from happening, it tells the person what the failure is, then they can go to the OEM support and be like, hey, my, you know, my hot end is clogged. How do I
Yeah.
fix this? Rather than just like going through all the troubleshooting steps. It would probably save um, printer manufacturers a lot of time.
Yeah. Well, another thing I think for 3D printer manufacturers, if you're watching, it might be a good time to start thinking about like including cameras with 3D printers. Like once QuinlyVision gets to the point where it can actually, like realistically catch a lot of fails, like most of the time,
Hmm.
a lot of people are going to want that. And having cameras as like a standard component on a 3D printer would be really useful for everyone as like a standard piece of technology.
Yeah.
Just like how now bed leveling sensors are becoming very mainstream.
Hmm.
I think maybe in the next two years or so, like cameras on 3D printers are going to be like the next leap in 3D, like FDM especially in technology. Because since bed leveling sensors, I don't really think there's been too much high tech sensing going on.
Not really.
Not really, right? There's like maybe the filament sensor that has the wheel that,
Yeah, like Ultimaker has a bunch of stuff, but it's all hardware based. It doesn't look at how your print's coming out.
yeah,
And Prusa's have like a lot of stuff that we integrate into Quinly, like self-calibration and a whole bunch of faults that Quinly responds to, but they're all like
mm,
electronics based. They don't tell you how your print is going, they just tell you if the printer itself is broken.
yeah,
Um, Al brings up a really good point, the 3D Print Oracle website. So for people who don't have it, could we set up a site that they can just send individual images to? And this is actually one of the
yeah.
places we want to take the demo to. So as the demo improves and as we can start accepting, you know, like a wider range of images, that's what we plan to do with the demo site is like allow you to upload your own pictures.
Yeah, I actually really am like a huge fan of the idea of having it like so if you have a issue, you can submit it and QuinlyVision will analyze it, but people will submit their comments and they'll draw their boxes and the people with the most accurate solutions will get voted to the top.
Yeah.
The people and those highest voted solutions will also train QuinlyVision. So
Yeah.
QuinlyVision will have its best guess but it'll try to move its guess closer to the most highest voted one. So we're like using the community because the community is the best source of knowledge
Hmm.
for such an open-ended problem like this. Like using the community to build QuinlyVision is the best way. And I really like the idea of like calling it, maybe not calling it the 3D print oracle, but that idea of,
I'm pretty sure we bought a domain for this purpose a few weeks ago.
yeah,
Yeah, I think
well,
so.
that's pretty cool.
Because we were talking about like a tool that people on Fix My Print could use
Yeah,
when the model gets better. Um, yeah, I'm pretty sure we bought a domain for it.
right.
Yeah.
Well, I want to see it. So, like, before you can submit your problem to
Well,
like
they'll be
a
able to do it
forum,
to QuinlyVision.com too.
yeah, you just go to QuinlyVision.com, you submit your image,
Yeah.
and it gives you like a list of at least some baseline things to
Yeah.
check. And then after that, then you can ask some real humans,
Hmm.
if your issue still isn't fixed.
Yeah.
That could be a fun way to start.
Yeah, I think we would totally do that once the model gets better.
Yeah, that could make,
Kahoot for print. Oh yeah, Steph says we did buy a domain for that exact purpose.
yeah,
I
cool.
can't remember what it was called though.
Was that actually, didn't we talk about this last live stream? And
Yeah,
then we were like,
I think
Steph, go buy the domain.
yeah, I think that's what happened. Imagine a Kahoot for print. Yeah, exactly. So that's something we want to put on our demo site, um, and then have like a leaderboard, and then eventually, as you know, after the Kickstarter, as the demo becomes built into QuinlyVision. We want to keep a bunch of games like that in QuinlyVision so that and like keep leaderboards and stuff like I don't know if people would like this, but like having a leaderboard for who did the most successful prints and who did the least successful prints by percentage or something.
Like the biggest loser
Yeah.
for 3D printing.
Biggest contributor.
Yeah.
Maybe we phrase it that way.
Well, hey, like some people just do a lot of really experimental prints. Like they're not
Yeah.
trying to do the most clean print. Like I do this, like I spent a couple of weeks printing intentional fails just to see if I could get something to work.
Mhm.
And a lot of my prints look terrible, but it's because I was just trying new stuff out. It wasn't supposed to look good.
Yeah. Live quiz sessions. Maybe every stream we do like a. Oh, that'd be fun actually.
Oh yeah, we could just go through and do a few ourselves and say, okay, this is what I think. This is what
Or
Mateo
we
thinks.
could like stream a quiz on YouTube and.
Oh,
Yeah.
we could do like a
Like,
live quiz where
yeah.
chat answers.
Yeah. That'd be fun.
Chat solves 3D printing problems. It's like Twitch plays
Yeah.
Pokemon, but for 3D printing.
Maybe that's the actual QuinlyVision engine is just it goes to a YouTube comment section. That
Oh, that
would
could be cool. There's like a constant YouTube live stream where you have to like sign in and or you just watch the stream and you comment what your solution is.
oh that would be exactly the type of thing that we would do. Like if you in some of these games, if the games involve like annotation or helping provide data, then like you would get free features in exchange for it or free months or whatever.
Yeah, like that's actually like a large idea behind this is that you'd like unlock certain things after doing a certain number
Hmm.
of annotations or getting a certain score. Um, because that's actually something we're planning to figure out a way to reward accurate feedback.
Hmm.
So if you just keep on spamming, you know,
Yeah.
incorrect information at QuinlyVision, we're gonna pick it up and actually you won't get rewarded for that. It'll have to actually be good quality feedback.
Yeah. And you can do that again, leveraging community, like seeing that idea where you have like the average of what everyone did, and if
Yeah,
you're wisdom of the crowd, right? Like if you're matching the average and matching what QuinlyVision was seeing, then you would get more points or something like that.
yeah,
Yeah, and yeah, we could do like a weekly or monthly ranking where like the top, you know, 10 to 50 people every week get like a free month or something. Oh, I guess it would have to be on every month would get another free month.
yeah. Well, that's if you keep on performing like in the
Yeah, you just get it
top
for
every
free
month, you
forever.
just get free QuinlyVision.
Yeah,
Like
exactly.
that's a fair trade. You're helping it grow and you get free QuinlyVision.
Call of 3D duty.
I like the names. Fix my 3D print hive mind.
That's like the subreddit, but the subreddit is I can't go on that subreddit. It's so I get triggered. Like it's some of the suggestions are just like, oh,
I go on the subreddit a lot actually. If you
yeah, I've seen your
yeah. I try
I've seen you on this subreddit. Like I agree with these. These are some
yeah.
good suggestions.
Yeah, you read the comment like, "Oh wow, that person really knows what they're talking." Oh, it's Steven.
Sometimes I read it, I'm like, what the heck is this guy saying? Oh, that's Steven.
Oh, it must be good.
Must be good. Yeah.
Yeah, I don't know.
Oh,
There's been a few times though where I've still learned stuff from Fix My Print. I'm no means like I don't know everything. There's been times where people have said like actually this common thing that everyone believes is wrong. I was like, what really?
I think there's some stuff that we disagree on too when it comes to slicing.
Yeah, we have different styles.
Yeah. Yeah, I don't print very I don't yeah, I don't print like you've convinced me to print 60 degrees hotter than I usually do. But
Yeah.
there's some things that I won't do.
Yeah, I recently actually discovered that you know when TPU goes into your extruder, it under extrudes because it gets squished.
Hmm.
It under extrudes in a very different way than I thought it did. I thought it was because it was getting crushed by the extruder and like the gear tooth dug in deeper.
Yeah.
And someone said, no, that's actually not why it's under extruding. Something else. And we
Okay.
had like 10 different comments, and then I was like, oh shit, you're actually right.
Yeah.
And yeah,
That's interesting. And that's exactly the kind of thing we need to build into QuinlyVision. So
Yeah,
that
well, we
like
want to find those experts that really know their stuff.
yeah, like if someone's printing TPU and it's under extruding, then we can make that suggestion. Then it can be like, hey, or if it's automatically trying to fix it, we know that with TPU we have to fix it a different way than with
Hmm.
PLA, for example.
Actually, that's a good point. If people are going to submit their photos, they should tag it with what material
Yeah, yeah.
and like
There would
basic
be
stuff.
there's some like you would tag printer, you tag material, you probably tag brand.
Yeah,
I don't think you'd have to tag color. We could guess color by looking at the picture
yeah,
most of the time.
yeah. Because this is stuff that QuinlyVision will know what printer you're using.
Yes,
Because you'll
yeah, that's
probably
true.
just type it in a
It'll know
box,
what printer
or
you're
you'll
using.
select it from a drop down.
But you'd want to know filament brands, and then
Yeah,
maybe we could even have rankings like what are the best filament brands that like what filament brands do people have the most success with?
yeah.
Um, what's the most popular new filament? Um, all those kinds of things because that's all like contributes to educating you as an operator. Like, okay, I should, you know, this PLA they're getting like 95 people on average are getting 95% success rate with a PLA. And I'm like,
Hmm.
maybe as a print farm owner, I should consider switching to that PLA. Same with silk PLA, it squishes as well. That I found that too with some silks.
Yeah, silk behaves in a different way. It's feels almost yeah, it just doesn't extrude the same way. I'm actually doing a silk print right now at home. It's a 2-day print. I need QuinlyVision at home
Yeah,
actually.
you
I
do.
don't know if it's failed.
You don't know
I'm
if
hoping
it's
it
failed
hasn't.
yet.
No,
Yeah.
it's been going since midnight last night. So
Oh, that's what you're asking. That's a giant file.
yeah, it's a giant
I
because
see. I
it's
see.
the first time I've sliced like a really high quality file in a long time,
Hmm.
and it was like a 200 megabyte G code file. So it took a long time to upload because my internet's slow.
Yeah. I noticed the rocks are very fast.
That's
Like,
good.
like I was getting, what did I say, 60 down locally.
Oh yeah,
It's pretty quick.
60 megabytes.
I mean, my router is not that good. So. Do we have anything else we should go over? I think we've kind of reached the end of
Yeah, I think we've
the
gone through
news.
most of it.
Um, I'll recap once again. Um, so yeah, get people signed up because this site. So on 3dq.com/QuinlyVision, or you can get to it by clicking QuinlyVision. Um, sign up here. Anyone you think that could use QuinlyVision either to learn about printing or who want to get involved with actually helping design the responses and providing feedback on new interesting ways we can look out and detect failures. Um, yeah, have them sign up here for the mailing list, and then what we plan to do with this mailing list, it's just QuinlyVision news, and obviously you'll get a link to the demo, and every time we publish something new to the demo, every couple of days, um, you'll get an update. You'll be able to check back, see has it improved or has it not improved or has it improved in a way that you think um, should be changed or whatever.
Hmm.
Every couple of days, there's going to be something new to come back and see and try out. And right now, um, we're focusing quite a lot on making it more interactive. In the next day or so, the live model will be actually processing images like what I was showing here, but with the nicer looking UI. Um, and then after that, yeah, we're probably going to put in some kind of accounts, some quizzes, all sorts of interesting stuff. If you have any ideas of what we should add, like I think that 3D Print Oracle is an excellent idea for when the model is better. Um, join the Discord or reply to, I guess, the emails from the mailing list. And yeah, let's like start that discussion because I think
Yeah.
yeah, this system is going to be huge for how we use 3D printers. And um, if we're going to change the 3D printing workflow, we need to have community experts at the core of that change.
Yeah, and I'm actually quite interested in hearing how you guys think it might be used as, um, like how we might be able to show this to like as an educational tool for people to submit their photos, or as
Mhm.
um, like more as like a leaderboard, like a game system where you know, as you increase you get points based on how accurate you were. You know, what would make it actually fun to use? Because we do want to make it like an enjoyable experience to build QuinlyVision together. Um, so yeah, your feedback is really uh, important to us. We want to know.
Yeah, and the more feedback, the better too.
Yeah.
Um, so yeah, anyone that you think might have like a glancing interest in this or might have some knowledge around um, building systems like this that might be interested in getting involved, send them to the mailing list, and then yeah, they can check out the demo, and we'll have call outs for more specific feedback. You'll get project updates as well. Um, yeah,
That's about it.
that is about it.
Thanks for
Oh,
watching. Thanks
thanks
for
for
joining us.
joining, Jeff.
Hey, machine creators. Joined at the last
Very
minute.
last second. There's some cool stuff, so definitely rewind. Anyone that's still with us at the end, make sure to leave a like on the video.
Yep.
Um,
And if you're watching this and you're not in our Discord, join our Discord. It's in our description on the video. Uh, a lot of really experienced 3D printing people in there. Um, a lot of people that use Quinly automation. So if you don't know much about 3DQ or Quinly, hop in the Discord, ask people who use it. You can ask us, people that work at 3DQ. Um, you know, if you don't know what we do, the Discord will answer all your questions as well. So
yeah,
yeah, give it a check it out if you haven't already.
yeah. I think collectively too, we've processed around over 300,000 parts
Yeah,
as a community. So, and now there are farms coming online, individuals that will be printing 300,000 parts next over the next year. So,
yeah,
uh, I'm yeah, that number is going to be like way bigger next year. But
yeah. Well, I'd like to say like 3DQ users are really good at slicing because they have to
mhm,
slice reliable G code.
mhm.
So it's almost like a self-selecting group of people that are now experts at slicing because you have to get reliable G code for automation to work well. So yeah, a lot of our users know what they're doing. So
Definitely
ask us some questions.
smack that thumbs up,
Yep,
Kevin
Kevin
says.
knows it.
All right. Well, we'll see you on the next stream. And yeah, we'll continue this discussion on the mailing list and in the Discord. Uh,
Yeah,
yeah,
that's it.
yeah.
Thanks for joining us on our first 2022 stream.
It's nice to see everyone. And yeah, we'll see you next time.
All right,
Yeah.
bye.